right. So we talked a little bit with curation that it's sometimes hard to find the right data. Oftentimes, one of the first techniques or strategies is to use the clip model. It's open source and you can generate embeddings. It works for both images and text, so it's quite versatile. But it's often not customized to particular use cases that enterprise teams are working on. So while it might be interesting as a starting point, it's usually not the end point for having custom embedding visualizations. So as a platform, when you're using, you want something to be able to like connect different data, different embeddings together. And on top of that, be able to select that data. When you select it, put it into annotation or through inferencing with GenAI models or other kinds of steps. So what you're seeing on the screen is just a visualization of Dataloop and how you're able to switch between embedding visualizations and then connect it to the rest of the ML tech stack. But one of the techniques that we helped one of our clients with is like they had a data set of 750K. They wanted to reduce that to a core data set of 500K. And they were using some of these tools and techniques to be able to get there. And part of it was with fine-tuning the clip model. Part of it was being able to take some of the labeled data, reduce it and clean it, and then be able to create a representation of that data inside the platform, and then like using those techniques together seamlessly.
This is one of the coolest things, which on the platform we see all the time is how quickly you can just run a model and find the data distribution. And the good thing is that it's not just distribution of data per the different attributes or classes, but you can also see the outliers, right? And the cases where you need to actually spend the human time more, because it's kind of very obvious that you need to spend more time on the edge cases and then first compared to some of the nominal cases that you have in the data set. And when the data set is simple, it's easy, but when the data set gets complicated and there are a bunch of things that you got to check on every single frame, then such data distribution and embeddings are super valuable.
Yasmin, that's like exactly like one of the techniques. It's like when you're starting a project, you're learning what is the way to build the knowledge on the items. And a good way to kind of see all of the edge cases at once is being able to get a diverse sample across the data set. So embeddings helps you find those diverse edge cases, annotate those first and take a look at those first and kind of like figure out what are the right ontology and the right breakdown for that data. Rather than getting, halfway through the project and realizing, oh, this is something we've never seen before, never encountered before, and need to adjust accordingly.
Exactly. And I think speaking about data curation, one other, it's not listed on the slide here, but one technology that's pretty common these days is also, your vision language models. So you can easily find, kind of objects and attributes from the objects using these like foundation models. There are a bunch of them that even Dataloop has and, which are kind of like industry standards. We as a company provide ground truth annotations for building these vision language models or vision language action models, depending on whether it's just a image search or an actual robotic product that's driving actions based on the actual data. That's another like thing that you can look into, to use from platforms like Dataloop in, kind of expediting your project objectives. Great. Let's move on to the next one. We are actually doing pretty good on time, so feel free to use Q&A to drop your questions, challenge us a little bit here. Otherwise, we're going to get bored with just presenting all the material. So please ask questions. We'll try our best to answer them. Okay. The other case study I have, speaking about pre-labeling, this was a very interesting project. So essentially, we were working with a partner to find the types of objects that people litter, garbage on the road, to basically quantify the environmental impact of that littering and garbage in a bunch of different public places across the US. And the task was pretty simple, right? I mean, here if you look at it, it's basically 3-step process. One is you need to annotate the trash or garbage object. Secondly, you need to annotate the bounding box around the picker, which is the stick or whatever method they're using for picking that piece of trash. And I think that was basically it, right? So then further you can classify the object into 100 different classes and subclasses to do categorization. But you can see the main contrast here is that you have the object and you have the background. There is nothing more than that, right? There is nothing subjective in terms of doing these annotations and so on. So what we learned is this is pretty repetitive. It's very low at the most moderate complexity and with a very well defined edge cases. Now only edge cases you can get here, as you can imagine, could be low lighting conditions. Maybe the piece of trash is not exactly centered in your frame, or maybe the collection device is kind of exactly on top of the piece of garbage or litter or trash, and that's why you can't see it. So these are the edge cases that you can get out of it, and they're pretty straightforward to kind of get through the human review and so on. So we use the sort of AI orchestration or a pipeline builder with Dataloop, right, and basically ended up creating a ground truth data set of a few thousands of your 2D images which were labeled by the humans. Then we trained the predict model, which was pretty straightforward given some of the existing models that are present in Dataloop, and the results were pretty straightforward as well. Like we are able to achieve a good amount of, like, what was important here was it was more of a recall, right? Like we didn't want to have any false negatives, misses. It was okay to have a false positive, like let's say a piece of stone was labeled as trash. Not a big deal, right? We can go and figure it out, but we didn't want to miss any actual piece of garbage or trash. So then we plugged that into the human review process. It needed a couple of iterations to kind of fine tune the training parameters to the model, and once we were able to find it out what works better, we pumped that in, spent a little bit more time on the actual QA and QC of the work than just labeling from the scratch. And at the end of it, the results were pretty good, right? So we were able to deliver this on time with lesser resources, or lesser than compared to if this was a completely manual workflow resources, and things work perfectly fine. So you can see in this particular image, it's just a pipeline visual that you can create in the platform, and it's essentially nothing but a drag and drop, and then you can connect the input output connectors, and then you can pick and choose model, its parameters. So it's very modular. Like it's essentially like you don't need to do no JavaScript or HTML to build a website now. You have all of these like website builders that can help you just drag and drop things to build a website. It's exactly like that, right? So this is very powerful for us to scale different projects and their requirements according to what we need to do, and it helps save a bunch of time. Yasmin, any reflections? I know you worked on this with the team. Anything you want to add or comment about?
Yeah, I was gonna say, like, the drag and drop pipeline like helps you build those workflows, like you said. It can go beyond that too, so I'll dive into that a little bit later with the next use case. Just like this is developer first platform, so if you want to go full into building scripts and like really customizing the use case, that option is available all the way to just drag and drop.
Awesome. And then here is just a quick result. So as you can see on the left, there are 3 different bounding boxes. The one in the bottom left was picking up the trash bag as a false positive, which then had to be removed, and then the right one is the human labeled one without that false positive. So yeah, I mean, we achieved a higher efficiency to cost ratios. As I was saying, the team was pretty limited in terms of allocation of work, and then it basically gave us confidence to use these tools better and more often in such projects. So I mean, the pipeline itself is very vanilla, but once you start building these pipelines is when you start realizing the effect of how these different AI orchestration tools or workflows can aid your human in the loop sort of a process. So I believe this is the last one from this case study. Yasmin has one more to share with us.
Yeah, so this is on the end of let's take a deeper developer approach into kind of automating some workflows. This was a LiDAR use case where they did have a ground truth data set already, but there were some model performance issues, and they wanted to diagnose what is inside the ground truth data set to kind of figure out what's going on. The other impact that they had was at the moment they are only reviewing kind of a very small sample size of the data that is annotated. So how can they better improve what they QC and have coverage of that? We looked at building an automated QC check into their pipeline. So in LiDAR, you have some very simple logical rules. Like for example, if there's a cuboid without any points in it, maybe there's no car there, or maybe that car is blocked by some other object. So you can check for these things in an automated way, and then using the Dataloop platform, append that metadata to the annotations, and then surface that for further QC validation by the team. So this goes from doing random review to having a more targeted and more effective review. It's finding the worst offenders out of the group rather than just looking at something at random.
Yasmin, how easy would you say it is to build these automation sort of validation rules or workflows? Can anyone, do they need to have any particular background in engineering or otherwise to build these, or it's pretty straightforward?
Oftentimes, data scientists and machine learning engineers are building notebooks that do these things, right? But their notebooks are specific to their environment, to their use case, to their particular small project, and it's not scalable to other teams, to other projects, and to other data sets. So what Dataloop supports is being able to scale those applications and make them easily accessible to multiple teams. If you go to the next slide, I'll explain a little bit about the platform so you understand how this is possible. We look at Dataloop in kind of like three primary layers. You have your infrastructure layer, which is where these automations, these scripts, what the team might build in notebooks require compute to run. So you have your infrastructure layer at the bottom. In the middle, you have your data management and orchestration. So once you have compute, you then need to do some things with and inside that compute. And at the very top layer, you have all of the applications, the end user experience, like basically the things that people interact with to be able to connect and create these experiences. So for the LiDAR use case specifically, what we are doing is taking an existing script that data scientists might have already built for their core QC check, something that they run off the side, bringing it into the platform as an application running on Dataloop's compute infrastructure or connecting to the client's compute infrastructure. And then that can be easily triggered in a pipeline, which is drag and drop. So as a project manager, if I am leading kind of this work, I can rely on my team to build the logic, and then I can run it as a non-technical user. So we provide that collaboration and the infrastructure platform to be able to bring all of these pieces together.
Yeah, the slide is very powerful. Kind of lays down every layer of the stack, pretty well. How are we doing on the time? I think we are a little bit early. We are, 10 minutes early. I can share a similar view on, in terms of our company and what we do for services. So we oftentimes, use these different layers when it comes to the data pipeline from ingestion all the way to data validation, and inject our experts and workflows with humans to kind of deliver on those project requirements. So it's a very similar stack-based approach, except that we have sort of processes and workflows and subject matter understanding instead of engineering layers. But this exactly works hand in hand with with the experts on our team who uses Dataloop or Dataloop-like platforms. So with that being said, I mean, it's perfectly okay if we finish a little bit early here.